So I'm going to kind of edit this video in an odd order. I'm going to talk about the final result first, and then we'll actually do the build. In the video to follow, I actually missed the fact that if we look at the ground prong on the US connector, the round one here, it's also tied to, so it's tied to the outer, let me grab the other end of the connector. This ground prong is attached to the outer metal case here, which makes sense. It's the shield, which is this line right here. It's also connected to the shield pin inside of here. What I missed was it was also connected to ground when I ohmed this out. We'll go ahead here and buzz this out just to show you. So I've got my meter set up here. Got it in a continuity mode. And if we take that third ground prong, we can see that it's connected to the shield. The outer metal can here, we can see it's connected to the shield pin inside, and it's also connected to ground. And then the build I'll do in the video, say further, I missed this connection here. So keep that in mind, because I didn't state this. This is the power supply brick that came with the Amiga 1200 I bought. It's a US power brick. I don't know if it's ever been opened or not. I haven't actually looked inside. On the back side here, it doesn't actually give current ratings. What's interesting on the back side of this one is it's labeled +5 shield ground, +12 signal ground, and -12. And in this case, in the schematic, this is of course shield ground, and this is actually signal ground, as that's labeled on the back. I don't think in the other power brick it's labeled that way, but we can take a look. Actually, on the other power brick, the pinout's not even defined, so it just shows a -12 output, a +12 output, a 5-volt output. Doesn't really tell you where the grounds are. So I think part of what confused me was I looked at this one and didn't look close enough at this one. So that's certainly something to keep in mind. I did power the system up without this connection, and it seemed to work, although that would allow voltage potentials to occur between the earth ground, the protective ground, and the system ground, which might be desirable in some cases, might not. So let's take the one I put the meanwhile switching power supply into. Before I go any further here, I do want to mention switching power supplies. This is the European switcher that came out of the system. I don't know if it works or not. Because this was a European supply, I couldn't use it here in the US without a step-up transformer, and I really didn't want to do that. Switching power supplies can be very dangerous, or can be high voltages. There's definitely high frequencies available. They can shock you or kill you if you're not careful. If you don't know what you're doing, don't open one up or research so that you understand well the hazards. This is an open frame switching power supply, which means there's high voltages present all over in here. The filter cap on this one's relatively small. It's all of 33 microfarads, but it's rated 400 volts. And the reason I mention the voltage rating is that's a 400 volt cap. There could easily be, on the back side of the board here, 300 volts across that cap, or 200 volts across that cap, or maybe even more than 300. And with the power supply turned off, that capacitor has a chance of holding that charge for a really long time. And reaching under the board, getting a finger across here could really hurt. Holding the board someplace here where I'm in contact with the ground and back there could pass that charge through my heart and kill me. Need to be careful is the point. You need to be careful with these. And again, if you don't understand this, do some research. If you do, I'll quote Mr. Carlson's lab here, you do at your own risk. A mistake I made in this is when I clipped the leads off, the protective earth the neutral and line for the incoming AC voltages are labeled here. The leads that went out to the Amiga are kind of shotgunned around here. There was a lead here, a lead here, a lead here that I think was ground, a lead here, and a lead here. And I know that the lead here was neutral. You can see the protective earth came up here and went through to that shield, which we did do with the build I did as well. But I should have actually labeled really, or got a good picture of where these leads come off of, and I didn't, because it did create a bit of confusion for me. So let's go ahead and open this guy up, and I'll tell you what I think worked out well and what didn't work out so well. Again, this is the unit that I've added the mean wall power supply to. I believe this mean wall supply is an 80 or 85 watt. You'll probably hear me repeat that stat several times. We'll actually pull up the data sheet for it here later in the video and take a look at the power supply I picked. And part of the decision was getting one that would hopefully fit inside of the original enclosure here. It should release the bottom case. So there's the mean wall supply sitting down inside of here. I'm kind of unhappy with the fact that it's in the case. It is upside down, which means hot air could get trapped in various places inside of here. It might have been better flipped over. The problem with flipping it over is that the board, because these plastic posts are wider than these plastic posts, the board doesn't fit down inside of here. And I didn't seem to have enough room to flip it over and clear the wider parts of these posts. And I thought about maybe grinding these down. The walls look fairly thin. I decided I didn't want to do that. I wanted to mount the board maybe in here on its side, except it was too wide to do that. So this may not have been the best pick for this. Kind of hard to say. As you can see here on the top of the case, I've got 4 screws going through. The purists out there may scream that this is heresy, because I have kind of spoiled the case. But again, I'm after a higher current capability power supply. Oh, that's tight. So that I have confidence on my A1200 with the various expansion boards and the USB, etc. on it, that I have enough current capacity behind the supply to not really tax the power supply, not overheat the power supply. Taxing the power supply will produce ripple. The system will become unstable. So the mounting here is just simply 4 brass standoffs. I've got a ton of standoffs, and these were the reasonable length. They are screwed down onto the board. You know, there's a nut on each side to hold it captive. I've got the line side on the US power coming into the switch, so I'm actually switching the line, the hot side, the neutral to where the neutral goes, and I've just taken the protective earth and grounded it with the solder lug, and we kind of captured that over here in what I did. Later in the video, you'll see me remove the pin headers and directly solder the leads on. The yellow here is the shield, and you'll see in the final build that I've taken, hopefully I can get this where you can see it, I've taken the ground here, so there's 2 pads here that are ground, and I've jumpered those around to the protective earth ground, and that protective earth ground is passed through the heat sink here, back over underneath this pad to where the solder lug lives here. So electrically, this now looks identical to what we saw with the unmodified US supply. Let me find the cables here and we'll prove that. So again, we'll get on the protective earth, ground, whatever you want to call it here, and the outer shield. The shield pin itself and the signal ground are all three tied together electrically, as they were in the other power brick. So I think from the interface looking on this side, this seems to be identical to what we had in the other power brick. I will say that when I sacrificed, and this was done off camera, the line cord from this power supply, I actually trimmed one of the leads on the incoming power cable really short, and essentially ruined that cable, and it would have been possible to cut the power plug off the end of that cable and put a US plug on, which is why I'm just using a regular line cord here. Anyhow, in the video coming up, we'll actually solder this all together. So let's go ahead and first off put this guy back together. It's a little tricky to get all the screw holes lined up. And it's going to be a bit of a pain. And again, if you want to yell at me in the comments for drilling holes in the top of the case here, feel free. I did what I did to get the end results I wanted. You know, and I probably already said it twice here. To get a beefy enough power supply that I'm confident the Amiga will run solid on it, as various workloads are thrown at it. Wow. I haven't had enough coffee yet this morning. Fingers are still clumsy. You know, a slightly smaller, physically smaller switching supply might have been nice. Oh, I've got a tangle of cables here. Need to kind of untangle these so I can get them to lay out. So inside of the case here, I'm actually taking the power lead and capturing it down inside of here for strain relief, and then when the top post is on, that's held in there pretty solid. I think that gives me a sufficient strain relief. Power switch, of course, comes out over here. System power out comes out over here. It's a little bit tricky getting all the wires tucked away inside. Getting this to all line up. There it goes. Just another little tip here is you can leave the switch hanging out. At least on this brick, it'll just snap down in, so you don't have to fumble getting it aligned perfectly. As always, take these self-tapping screws into plastic, turn it backwards till it clicks. Hopefully you heard it click there. That is the thread on the screw dropping down into the threads that were cut the first time the screw was turned into the plastic, or at least the last time. This helps keep you from eventually stripping out the plastic, because you're reusing the threads. And as you can see with this build here, you get a very solid click when it drops down in. If people, unlike their Amiga 500s, used this little tip, the case screws wouldn't, wear out the plastic nearly as quick. So really, we're back together. I realize this isn't very pretty here. If I had a grommet or something, I might have put that on there, but I don't. And again, it's good enough for my needs. On is, of course, up. So when the brick is sitting. Say airflow in this. There are vents here in the bottom, so it can draw in cooler air. And of course, the hot air exit from the top. Like I say, with the board in there upside down, there may be some spots where it generates heat. The Amiga supply is a decent quality supply. It wasn't all that expensive. So, kind of with the view here of the final product and that discussion, we'll jump into the actual build. So one of the things I'm going to need for the A1200 is a little beefier power supply. You know, with the expansion card and the cards I want to add, and you know, USB ports that could provide, you know, an amp or an amp and a half of current. The original power supply just isn't up to the task. This is that power supply that came out of that junk box. It was a European supply with this board, but you know, this board's set up for European power. It's designed for 220N, so it doesn't really do me much good here in the US without a step-up transformer. And I really didn't want to go to the work of that. I don't know if this power supply is any good even. You know, I don't know if that's blood on the side of the case. It looks like it probably is, so it's probably not a red mark saying this is bad. But this is the power supply that the power cable that I ended up with came from. It's got red all over it. And this is the cable I've been using from my Rigol bench supply for the experiments here on the bench. But I'd like to incorporate this all down into, you know, a standalone unit. I want to replace the original European power supply with one for, you know, set up for North America, 120 volt. This is a Meanwell, and I'm trying to remember part number. Is it on here someplace? There it is. Well, kind of there it is. PT65 R17 VA. This is a 5 volt, 5.5 amp. I believe the plus 12 is 1 or 2 amps, and the minus 12, actually here's the ratings on the side. Output 5 volts. Wow, that's hard to read in there. And as always, let's swap glasses to get me a little better view. So it's 5 volt, 5.5 amps, 12 volt, 2.5 amps, and minus 12 at half an amp. So really the plus 12 and the minus 12 are overkill, but it gives me 5.5 amps. It's 80, I think this is an 80 watt supply. So this should be a pretty significant upgrade from, you know, this 2 amp or 3 amp on the 5 volt supplying. Should give me plenty of overhead for the processor card and the other hardware additions I want to add to the system. Part of the decision to buy this was not only the capacity, but the physical size. Based on my measurements, I thought it would actually drop down here into the bottom of the case, but it's just a little too big to get around those mounting posts, which is kind of sad. However, with that said, it does actually fit in the top half of the case. So it can be mounted in this case. I want to mount this in a way that I do have airflow. I don't know if I can mount it sideways. I actually think it's too tall for that. Yeah, it's a 1/4 inch too tall for that. So this is most likely going to get mounted. Debating whether to mount it upside down so I get better airflow over the components. But it'll be mounted in the bottom of the case here. I may mount it on some standoffs in the bottom here. You know, I can get it in the case, stood up like that, or upside down like that with plenty of room. Actually, that wouldn't be upside down the way I have it there. So actually, I do want to mount this. I think I'm going to hang it upside down. This is the bottom of the case. I'm going to hang it upside down this way so I get airflow in the vents on the bottom directly onto the electronics and the heat sinks, and then it can come around to the side of the boards and out the vent on the top. I've still got the power switch that was in this box originally. That will be reused. I believe the power switch sits in there. And of course, I've still got the cable with the strain relief over here. The outputs here, these wires will come directly to these outputs. I think I'm just going to unsolder the connector here and directly solder the leads for the outputs to the PCB, and that way I don't have a contact in the middle. I've just got a line cord that was cut off of some piece of gear at some point that was salvaged. This line cord will be used. Actually, this output may go over here on this side. And the line cord comes in back here by the power switch. I believe that's actually the correct orientation. I'm debating whether to try to fit like an IEC plug in there, but I just don't think I have room. So this, I'll have to think about what I'm going to do here. Yeah, say there may not be room. Get it the right orientation. So there may not be room for everything I want to do here. So this just may become power cord directly in the hole here, and probably honestly come in and essentially wire tied over to this post to give it some strain relief. We'll kind of figure that out. It is a fused supply. I mean, it's a mean well. It should be a decent supply. I'm making some assumptions that this supply, some of the older mean well supplies require load, unlike the 12-volt line, in order to have stability. Otherwise you get a lot of noise. I don't think this power supply is old enough to have that issue where there's got to be a load. The protective earth, the earth ground, whatever you want to call it here, will tie to this post here. And that protective earth does come through, it's passed through the body of this heatsink to this output over here. And the shield, and I don't remember which wire here is the cable shield, and then goes to the RF cage on the Amiga, will be picked up from over here, actually from over here. So I will take the time to pass that protective earth all the way through, as was really done on here. As I recall, when I removed cables from this, the wiring in this was kind of a mess. And you can see where I removed leads. But yeah, the protective ground came in right here from the line cord, and then was passed along here to where the shield wire for the cable out was. So, you know, I will be definitely following that practice. This does have a nice adjustment on the 5-volt out, and so when it's together and done, whatever cable losses are here, I can just bring the supply up here. You may have saw, or at least I talked about when I was using the bench supply, about the Amiga 500 with, or even the 1200 with some load. There was about 0.2 of a volt loss in this cable on the 5-volt rail. And so I actually brought the bench supply up to 5.2 volts, so I got a nice solid 5 volts inside of the computer. I will use that adjustment, kind of do the same thing here. 4.8 volts or so in the computer is perfectly acceptable, but since I can tweak it up to 5 volts in the system, I will tweak it up. So anyhow, that's kind of a quick introduction on what we're going to do here. This video will probably be 2 or 3 pieces as I move forward with this, but I'll take you through the process and we'll go from there. So in the A500 project, we ohmed out this cable to figure out what leads went to what pins, and I can't find that drawing. So I'm going to go ahead and re-ohm out the cable here. So I've got the multimeter in continuity mode. And as I recall, the red actually was the plus volt rail. So the red should come to this pin down here. And it does. So this is red. And so red leads a little heavier gauge than the brown, yellow, and white. As I recall, black here was the actual ground, which is this pin up here. I believe was yellow the shield, that I'm not sure of. Yep. Well, I think it is. So yellow is going to the outer shield here and to that pin labeled shield. Now, if you're going to do this yourself, certainly ohm your cable out. Nothing guarantees these colors are consistent across multiple cables. White is either going to be plus 12 or minus 12. Looks like it is minus 12 in the center here. And that means brown, which is the only remaining wire, must go to the plus 12 volt lead up here. And it does. So we have the pin out of the cable again. On the power supply here, we have pins 1 through 6, which are the output voltages. And so pin 2 and 3 are the plus 5. So pin 2 and 3 are plus 5 red. We have 4 and 5 are ground, which goes to black. We have 6, which is V3, and 1, which is V2. And I believe, looking at other pages in the data sheet, this we'll have to verify this. That that's going to be, I believe, the plus 12 actually, or brown. Meaning that pin 6 then must be voltage 3 or the minus 12 white. And we will confirm that, of course, before we plug anything in. So I'm going to approach this by getting the power supply leads hooked up to it and the switch in place. And I'll power it up and measure these just to be sure. And we'll go from there. So let me set some of this aside. I really probably should use the desoldering tool to desolder those. So let me find the case, as it's got the larger nozzle in it. Just hopefully it has the larger nozzle in it. It's supposed to. Yeah. And hopefully this nozzle is large enough to go over these pins, and it is. So I should be able to use this nozzle here to desolder. Let me move some stuff out of the way. We'll swap out the tip. And turn the tool on. It'll take it a few seconds to warm up. I wish I had some place to capture these tips so they didn't get lost on the bench. And like I said, we'll hook power up first and then we'll go from there. So, and on the incoming side, there should be a neutral and a line. So according to this, pin 1 is the neutral. Neutral, and that should be the white wire. And line is on pin 2, and that should be the black wire. And my line cord doesn't really look like an N. And of course the switch, wherever the switch ended up, will go in line with all of this. And I'll be switching the line side. So the switch is going to get attached to the line side and then to the board, and to the board. I do have my shrink tubing here. In a previous video, it had vanished, but it has shown back up, luckily. I don't know if we're hot enough yet to actually desolder. Maybe. I could just find the correct Molex connectors here. I honestly don't know if I have the right ones. That pretty much releases the connector. The holes are nice and clear. So I need to get some shrink tubing. Fire up the soldering pencil since I will be soldering these leads. And find some black that'll be large enough to do this, and I think that's too fine because the size of the solder joint will become maybe, maybe not. Got, of course, tools laying everywhere. Don't know if that's a better diameter or not. Kind of do a pigtail on those. Oops, I have the second piece of shrink tubing I wanted to put over the first, so get it slid into place and reattach those. I'll bet I've got a fine tip on there, and I want a large tip on the tool, so I'll go ahead and swap in the larger tip. Give it a couple seconds to heat up. I've actually got even larger tips than this that would probably actually do a better job here, but this will get the job done. You can see that the copper here is already taking solder very nicely. Oops. Let that cool for a second. Let me get the heat shrink tubing heat gun. Apologies for the noise. Shrink this piece. And I'm going to put the larger piece over it and shrink that over the top so it's a double layer, which you probably can't hear me over the fan noise. There'll be a little bit more heat shrink work on this. Hang that out of the way. Ouch. I'm going to go ahead and tin these two leads up. Don't want a ton of solder because I need them to come down through the holes on the PCB, but it'll be easier to solder these up if I tin the leads a bit first. Trim that big solder ball off the end. Oh, tinned the wrong one. Even though this is an old line cord, the copper in it's still nice and pretty shiny. You know, it was a quality line cord in its time. Got the power supply module. We said the neutral is up here. we've said the line comes up through here. And the protective earth is actually going to go to the lug here. Assuming I can get the lead to go through the hole in the lug, and I may not be able to. There it is. I'm just going to solder directly to the tab there. Now, this is probably not up to code doing it this way, but it is what I'm going to do. That really does get me power to the board. So let me get a ground connection here. We know that either one of these two pins is ground. I'm just going to get down over that with some insulation. Go back to volt mode on the meter. And hopefully we won't see smoke and fire here in a second and get this turned here where I can get to the leads without touching the supply. That's isolated. Power switch is off. Hopefully I'm not about to see smoke and fire. So I believe it's going to be plus 12 to here, and it's 12.15 volts. Should be plus 5, and it's measuring plus 5.09, and this should be minus 12 here. And it is, so I've got the layout here correct. Of course, now I've got a fair amount of charge in that large filter cap there. So I need to be a little bit careful around this. Not knock myself on my ass. Let's go ahead and see what we've got on there. Just curious if that cap has bled back down or... Yeah, there's 5 volts. It's dropping off. So there's not a huge charge left on there, 4 volts. Actually, just at this point, discharge it. That's low enough. Yeah, 100 millivolts. I should be plenty safe now to handle this. We're going to desolder this connector off. I need to be sensitive not to get that surface mount component there knocked loose. You may have seen that the connector just fell off, which is absolutely fine. We want the Amiga power lead. And we've said that brown. So with the system this way, plus 12 is here, which is brown. Which is actually this side. We flip the board over on this side. Get that lead pushed up through there, and we'll tack solder that in. Solder got out of the little guide on the solder holder, and we'll just attach that wire here. And red comes to one of the next holes, which is right here. So let me untwist these. They're kind of all twisted around each other. Get it a little bit cleaner. +5. Just use weight to push the wire up through there tight. There's a lot more copper pore here. So let's take more heat. And it's a heavier gauge wire. That should get me +5. We're then going to skip 2 holes to get to the ground over here. Same thing, it's got 2 holes, a larger copper pore and heavier wire, and that actually didn't solder very nicely. Why didn't that solder well? And white should be -12. It should come to this end down here. Does that look like I didn't? Yeah, that didn't solder real well. Reheat it, reflow it. It's not being happy. Though honestly, the -12 is pretty low current. And if the board flipped this way, we should be white, ground to one of the 2 ground pins, VCC to one of the 2 VCC pins, brown to the +12 pin, and yellow is going to come off over here. So this is going to take a little bit of deciding how this is going to go into the case. I need to have enough length here to float this in here. And I'm wrong way around. Okay, that's much better. It's going to float in here something like this. I think I'm going to have to extend the yellow wire a bit. I don't think it's quite long enough to get over here to the where it needs to go. So I'll have to add a piece of wire to that. Get a little more length. So let me find a piece of donor wire. Almost feels like it's solid core. No, it's stranded. Come on, attempt to wrap around there. Get enough there I can get it to take solder. high point off. Need some yellow shrink tubing. This might be large enough diameter, or it might not be. Yeah, it goes over, it's just really tight, so we'll start with that. Heat gun back. Now it's just really kind of deciding how I'm going to, if I'd have gone longer I could have just routed it directly over to here. But I don't think I went long enough to do that. I really am going to end up tying it onto the PCB here. I'm not going to be able to probably solder it to that the heat sink lug there, just because it's so bloody large. A couple of mauves there, maybe in there. Yeah, this isn't exactly super elegant. I really want the 4 screw holes to use for spacers and mounting. I don't really want to leave it just flopping around loose in there. Let's get some fresh solder on the side of these mauves. No, it's not elegant or beautiful, but it will work. So really the question now becomes, are we seeing the expected voltages? Almost tempted to tack a ground pin in there just to make it easier to hook things up. Let's see, ground is those two. I'm just going to tack this on here for now to give me an easy point to hook the voltmeter up to, so I can measure without hopefully screwing this up. Wow, that's just wonderful. That's just temporary there, just long enough to be able to get a ground to the voltmeter, make this a little bit easier to test. We've got our end here. Go ahead and plug the power supply back in, and hopefully it won't explode here because I've done something stupid. Let's take a look here and see if we're seeing the expected voltages. Minus 12. Don't want to slip and short things. Come on. Oh, plus 12. Okay, that's brown to plus 12. That should be 0 volts because it's ground. It should be minus 12 in the center here, and it is. This should be plus 5. That's the 5.09 again. And that's, of course, the shield ground, and I should see nothing. So, plus 12. Damn it. I slipped and shorted. I heard it. God, why can't I? No. Oh, that's frustrating. Plus 12. Minus 12. Plus 5. This is, of course, ground. This is shield, which is tied to the can out here. So I think we're good. Really now it's just a matter of getting it mounted well in that case. Go ahead and flip this back over. And I'm just going to pluck that temporary ground connection off of there. Just not loose solder. Hopefully this will give me a nice stable power supply with current overhead. Such that the Amiga will operate fine. So I need this to come around this way. It's going to sit in here. The power switch will, of course, sit down in here. The line cord needs to be tied in. This needs to leave enough room here. For the top of the case, which is this way, I believe. And we've retrofitted a European power supply adapter with a brand new Meanwell 80 watt, I believe it's an 80 watt, maybe it was 85 watt power supply, so it should be plenty. So anyhow, I won't bore you with drilling holes and putting studs and stuff in, but there it is. We'll talk soon.